So as you can see, I put my NASA hoodie today, but hopefully this topic is not gonna be a rocket science. From the top, people, from the top. Hello YouTube, it's Derek from DevMentors and welcome to second episode of Messaging in Distributed Systems series. So for those of you who don't know, this is the series which is all about the most important topics around the messaging, and we're gonna to cover them in depth, meaning not only from the code's perspective, but also from the theory and the concepts. So hopefully you'll get the deeper understanding about what happens in our messaging system. Today's topic is, I would say at first glance it might look trivial, but I can guarantee that once we'll start going deeper and deeper, you will see that in certain cases, a few things will not be that obvious. And the topic is message delivery and message delivery guarantees that certain message brokers can provide you. So let's just jump into it. Before we go into message delivery guarantees, I think that we need to ask a very fundamental question first. So when can we consider message to be actually delivered? And honestly, it's not that simple to answer, because depending on the perspective, we could consider a different point of time in which the message is actually delivered. So let me give you an example. We could think about the message being delivered when we get the acknowledgement on the protocol level, let's say on the TCP level. So we have the ACK being provided, and this explicitly can indicate that the message actually has been delivered. Or maybe the point of time in which we received, let's say as a microservice, the last byte of the message. So now we have all the bytes which can be decoded and processed within the boundaries of the microservice. That could be also being considered as a delivered. Or we can think about the situation in which the message has been decoded and all the side effects were actually executed. So let's say we had something, we need to calculate something, put this into database, send an email, call our customer, whatever. Certain side effects that has to be done to consider this message to be delivered. Now, this last case, I would rather like to call a message processing rather than the message delivery, because you will see that depending on the term, we could guarantee certain scenarios, and in other case, we just simply can't. So this first two, I think that we could consider theoretically as a message delivery, while the third one is rather the message processing itself. Now, knowing this, let me just explain what this whole message delivery guarantee is all about. So once you build your distributed system, of course, there is a tons of different scenarios that you probably need to cover in terms of different types of communication that we discussed in episode number 1. So maybe choosing between synchronous and asynchronous communication. But even if you are already, I would say, sure that the asynchronous communication is the one that you would like to choose, you still have some sort of options and scenarios in which you might choose, let's say, more relaxed version of the message being delivered rather than more strict. So starting from the, I would say, most trivial in terms of work is so-called at most once delivery. I guess the name is kind of self-explained. This effectively means that the message could be either delivered once or not delivered at all. And the fun fact is that we actually used this guarantee in episode number 1. Of course, once we'll jump into the code, we will see how it was done and how we can eventually switch to some sort of more restrict guarantee. But the way it works is actually very simple. So once the consumer gets the message from the queue, it's already being marked on the message broker level as delivered, which means that now we might have two different scenarios. Scenario number 1 is that the message was physically delivered to my microservice and was processed in there, and I got this at most once delivery guarantee being fulfilled. On the other hand, there might be a situation in which something went wrong. So either on the microservice level, I got some issue, or maybe microservice just collapsed, shut down, there was some error or whatever. Or I could have the issue even on the network level, famous and mentioned in the episode number 1, fallacy of distributed computing. So network being reliable, which sometimes is not simply true. We might think about some sort of network partitioning happened, and effectively, physically, the message as a whole sequence of bytes could not be delivered to the microservice. So in this case, we got at most once delivery also being fulfilled as a guarantee, because we actually didn't deliver it. So you need to be aware about this model, and you can already see that you probably don't want to use it everywhere. Because think about this, if you decide to build a distributed system, and let's be honest, I mean the messaging, knowing that the microservices needs to be fully decoupled, I mean ideally, you need to strongly rely on the message broker itself as a sort of infrastructure part that is responsible for this messaging delivery. Then if once a while the message is simply lost, I mean, depending on the context, this might not be harmful in one case, but in the other, this might be crucial. Even considering our current, superstore system, if we build a logic on the card service, which basically is nothing more but the projection of customer funds, then can we really afford the situation in which the found message never gets delivered to the microservice? Probably not, because that would mean that we have very inconsistent state when it comes to the amount. On the other hand, if we have some sort of maybe logging microservice, something which is barely used, or maybe we don't care as a whole about the sequence of the messages, but yeah, once a while we can just afford the fact that the message has been lost, this model is very good, especially in terms of performance, because I'm acknowledging the message delivery ahead. I don't need to wait for anything else. So in terms of performance, is very good approach. Worth mentioning that this approach is also called fire and forget. I would say more from the publisher perspective, I'm basically calling sending the message and I'm forgetting about it. So hopefully this will get delivered, but if not, then who cares? So maybe the issue with at most once delivery model lays into the time of the ACK, because if I'm acknowledging the message delivery ahead and still the message is not even physically in the microservice, that leads to some serious issues. However, what happens if now it's the application's responsibility to provide me the NACK? Well, that's something different, because now at least I am ensured that once the ACK is being provided, then the application itself considers the message to be, either delivered or even processed. From the message broker perspective, we don't care. The only thing we do care is to have this ACK. What type of guarantee we are actually talking about? Because someone may say that, okay, now this is the perfect situation. This is exactly once delivery, because I'm giving you a message and I'm expecting the ACK. If the ACK is being provided, you got the message. However, what happens if the ACK is not being provided to the message broker? Well, of course, this means that the message was not delivered, so when I will give you the same message again, like the duplicate, you should, eventually get it and process and return me the ACK. Simple as that. Now, the bottom line is as following. The exactly once delivery in distributed systems is simply not possible. Period. It's proven, it's not possible. If someone claims something different, it's simply wrong. And the proof actually can be based on the two armies problem or two armies paradox. If you don't know it, well, now is the time to explain it. So let's just time travel into medieval times when there was no such thing like a modern technology which could allow us to easily communicate with each other, like no cell phones whatsoever. And imagine a city which is fortified and defended by some troops. Now, on two sides of the city, there are two different armies led by two different generals. Let's just call them General A and General B. The defenders of the city are actually strong enough to defend against one army. However, if two armies will decide to attack at the same time, the city will be captured. For those two generals, it is extremely crucial to agree on the exact time at which both armies will perform the attack. Now, because we are in the medieval times and there was no mentioned cell phones, they need to communicate by sending a messengers through the valley which basically lays between those two armies. However, there is just tiny detail. The valley itself is occupied by the city defenders, so there is a chance that the messenger will be actually captured and killed. So each of those two generals cannot be sure whether his message was actually delivered or not. Now, let's just imagine the following situation in which one general sends the message with the attack details to the another. So let's just assume that General A sends a message in which he indicates that he would like to attack next day at 6 o'clock. The messenger carries this message into General B. General B reads it and responds with the confirmation message. So he can just confirm that he is ready to attack the next day at 6 o'clock. Now, the confirmation actually carried by our messenger is being delivered to General A. Now the question, does it mean that both General A and General B are 100% sure that the attack will take place the next day at 6 o'clock? Now, from the General A's perspective, the situation is pretty clear because he proposed the time and he has the acknowledgement being sent by the General B. However, the General B received the details regarding the attack, he sent the confirmation, but he's not certainly sure whether the confirmation got delivered into General A. In this case, he might be wondering if the confirmation was not being delivered, so there is a chance that General A could not get this message, so he could not be ensured whether I actually got this message because for some reason he's not getting the confirmation. What should actually happen? So the obvious outcome of this issue would be sending a confirmation by General A to General B, in which he could just briefly inform that he received the General B confirmation. However, now in this case, it is the General B who's ensured that everything went smooth, and now the General A is not quite sure whether his confirmation was received by General B. So you can already see that there is like the infinite loop of being not certainly sure either about General A or General B. Now the problem itself is even more interesting if we consider the alternative scenario. So let's consider the following. General A sends a message with the details about the attack to General B. However, after a couple of hours, he does not get any sort of confirmation message. Now in this case, two possible scenarios could happen. A being that the message from General A actually was never being delivered into General B's hands because the messenger was being captured. Now on the other hand, there could be also that the General B received the message but his confirmation was never get into the General A's hands because the messenger has been captured. So you could clearly see that in any sort of scenario, generals will not be 100% sure whether the attack should be performed at the specific time. Now this two generals or two armies paradox actually has its natural continuation when it comes to the overall consensus of the decision, also known as the Byzantine generals problem, but those two are not the same issues and each of them addresses slightly different thing. So for now, let's just leave the Byzantine generals problem and let's just get back into the video. So hopefully you can see where is the issue. With, knowing the paradox with general A and B, in our case, one general A could be our RabbitMQ, our message broker, while general B could be our microservice. Now, if the RabbitMQ does not get the ACK, it is simply impossible to determine what happened. So whether there was a network partitioning between the Rabbit and the microservice, and this message never gets into the boundaries of this process, or maybe the message was actually delivered but microservice collapsed and that was never processed, or the message was delivered, processed, but there was some sort of issue in terms of providing the ACK because maybe we had the network partitioning between the message broker and the microservice itself. So the only way to provide you some sort of guarantee that this message will be delivered at least once is to send you message again. And this is why it is not possible to talk about exactly once delivery, but rather the only thing that I could provide is that the message will be delivered to you at least once. Basically because in situation in which I don't have the ACK, I'm not certainly sure what happened. Model with the providing ACK on the application level, it's at least once delivery. Now, I mentioned at the very beginning that delivery actually isn't the fact that we as a developers are very focused on. And honestly, message being delivered more than once is not a big deal for us, to be honest. Because first, if you build your whole logic of the message processing in idempotent way, so idempotency was also covered in the episode number 1, then does it really bothers us that we'll get the multiple execution of the same message? No, because the overall effect will remain exactly the same. So think about the example. If based on the message I need to update my email from A to B, then first, update in this case is idempotent by nature. So if I change the A to B in my database, then I will just update B to B with all new incoming duplicates. So eventually, if I will even process this 100 times, the overall result is that now my mail is B. Number of times is not very important to me at all. However, what is also important is that, when we can't provide you exactly once delivery on the network level, we can actually provide on the application level exactly once processing of your message. So we can create the logic within each of the microservice, which will ensure that no duplicate message will be processed within the boundaries of the certain microservice. So exactly once delivery, impossible, don't think about it. However, some people, when they spoke about the exactly once delivery, what they really mean is exactly once processing of the message. Simple as that. Now we've talked and we mentioned this ACK, so this acknowledgement. So I think that it is good to discuss it in more depth rather than just ACK. What is actually the ACK? Well, in RabbitMQ, once you have the message being consumed by the consumer, the message carries, as you know, some sort of additional properties, headers, etc. And one of the property being carried with the message is so-called delivery tag. So first is that this tag is an integer, actually monotonically growing integer, which has 64 bits of length. So I will just put the maximum value that you can have, something like this. And what you also need to know is that the delivery tag and this monotonical growth is scoped per channel. So each channel may keep this incremental process within its boundaries. Now, when the message is being, either delivered or processed, because the ACK, providing the ACK is very up to the microservice. When will be actually being sent to the back to the RabbitMQ, what you need to provide in this ACK is delivery tag. So I'm explicitly saying that I want to acknowledge deliver of message with the tag equal to 2 or to 3 or whatever. Now, there are two things that you cannot do within the ACK even if you have the delivery tag. First, obvious, you cannot acknowledge the message with the delivery tag that has not appeared in the Rabbit. So if I, as a channel, my, let's say, latest message comes with delivery tag 100, I cannot acknowledge the message, let's say, with the delivery tag 2000, because it didn't even appear, so it makes no sense. So I cannot acknowledge ahead. The second thing is that I cannot acknowledge the message from different channel. Because it's code by nature per channel, then you only can acknowledge the messages that has been consumed using the particular channel, period. Another thing which is also important is that the acknowledgement actually can be applied either to one, so single, or multiple messages. So within the ACK you have the multiple parameter, and if this multiple parameter is set to false, then it means that the delivery tag is the only message that should be acknowledged. However, if the multiple is set to true, then it means that every single message up to this delivery tag should be acknowledged. So assuming that I would have, let's say, 10 messages unacknowledged, and I would send the ACK with delivery tag equals to 10 and the multiple parameter set to true, then sending this one ACK to Rabbit would acknowledge all 10 messages, because all up to 10 would be acknowledged. One thing though, which is also worth mentioning, is that in most message brokers you actually have an ability to provide you not only, let's say, a positive acknowledgement, but also a negative acknowledgement. So in short, NACK. Now in RabbitMQ you actually have two types of negative acknowledgement. So first is NACK, negative acknowledgement, and the second one is reject. So what's the difference? Well, the only difference actually is that the reject applies only to single delivery tag. So you cannot, as mentioned, you cannot provide the negative acknowledgement for multiple messages, while in the NACK it is possible. Actually, reject was the first negative acknowledgement, and because of this capability with this multiple parameter, this NACK was introduced. So when we think about some sort of confirmation for the RabbitMQ, there are three options: ACK, acknowledgement, NACK, negative acknowledgement, and reject, also negative acknowledgement, but with no option to be applied for multiple delivery tags. Speaking about the ACK itself, also it's worth to mention so-called prefetch count. So prefetch count is nothing more but the number of unacknowledged message that can be handled within single microservice. What does it mean? So in the previous video, when we used this at most once delivery, implicitly the prefetch count was set to 0, which means infinite number. The infinite number of messages could be unacknowledged and processed within our microservice. The benefit of this is that it actually is way more performant, because if I have this set to basically infinite, I can just consume every single message that appears in my queue, consume it and process it. The drawback is that because there is no certain threshold at which I stop consuming the messages, even if I haven't finished processing the others, the drawback is that it basically affects the resources my microservice is using, so RAM and the CPU or the hard drive. So I would say that 0, so the infinite, when it comes to prefetch count, is not ideal in all cases. On the other hand, if I would set the prefetch count to, let's say, 1, this means that it's very much the sequential processing, because I can only consume one message, and now even if queue contains way more messages, I cannot consume another one until I will not provide you the ACK. So this is, on the other hand, I would say not very performant, because yeah, I can just process one message at the time. I need to provide the ACK. You also need to include the latency between sending the ACK and receiving this on the RabbitMQ level, and also waiting for another message to be consumed. So not very performant. However, there is also a good thing about this, because when we can process effectively only one message at the time until we provide the ACK, there is no race conditioning. There is no situation in which two messages are basically processed in parallel, and maybe they are using some sort of not thread safe resources. So I would say that in not every case this should be considered as a bad practice. Pretty much, once again, depends on the situation. But of course, it's should be this whole sweet spot where it comes to the actual number of the unacknowledged message at once should be something that you as a software engineer should be responsible for. So maybe in one microservice the prefetch count would be set to 10, in other this would be 0 because it could be infinite, in other this could be 1 because you don't want to have this race conditioning, and if the technology provides you an ability to do so, something that could not be done, let's say, on the HTTP level, because you cannot block another calls to your API, yeah, this could be treated as an advantage. So it's good that you have this ability to adjust the prefetch count, and I would say that it's worth mentioning that the prefetch count itself, for now we'll just maybe not focus on that, but may impact your overall ordering of the messages and the way that will be processed. But once we'll cover the total and causal ordering, you'll see what I mean. One thing though, which I forgot to mention, when it comes to negative acknowledgements, is with the NACK or reject, you have an ability to specify whether you would like to put the message back to queue or just discard it. Now, once again, you might think about the different scenarios. So if there was some exception while processing of the message, maybe because of the business logic, probably if you will run the same message again, you'll have the same exception being thrown from the domain, and yeah, requeue makes absolutely no sense. While on the other hand, if the exception was more like based on the infrastructure, maybe third-party service was not available for a second, or there was some sort of other timeout exception, yeah, considering requeue could be an option, because maybe in the meantime, while this message will be put back into the queue and consumed by the microservice, maybe this third-party system will be available again. So once again, you have this flexibility as a software engineer to adjust and determine. Of course, putting back on the queue is not the only option. Once we'll cover the error handling in depth, we are going to see what are the other alternatives in terms of error handling. But I just want to indicate that there are certain options regarding the NACK itself. Now, last thing that I wanted to cover is the publisher confirms. So just like you have the ACK on the consumer side, you also can provide in certain situations the ACK also for the publisher. And of course, it doesn't necessarily mean that the publisher will get ACK once the message has been consumed, because that would be odd. It's rather the certain situations, and depending on the message type, you can have the ACK on the publisher side as well. So what I mean, in the scenario in which the message is not set as mandatory, so mandatory means that there needs to be at least one queue binded to the exchange in which I will put this message. If this is set to false, so I don't care, even if I will evaluate that there is no queue into which I can put the message, you'll have the ACK on the publisher side. In the situation in which I'm sending the persistent message, which needs to be also saved into the disk, you'll get the ACK once the message is successfully persisted onto the disk. And in this situation, you can already see that for the publisher, this information is crucial, because if I don't have the ACK, this means that the message has not been persisted into the disk, equals, okay, I need to resend it or do something else. So depending on the scenarios, this might be useful, but of course, in most cases, it's rather the consumer who needs to provide the ACK to our message broker to indicate that the message has been delivered and probably processed. So to sum it up, when we think about delivery, delivery is not equal to processing, and we as engineers rather care about the executing side effects and the processing of this message. Now, when it comes to message delivery guarantees, you can have this situation in which I acknowledge the delivery ahead, which effectively means at most once delivery. Message could be sent either could be delivered either 0 times or 1 time, or the situation in which the ACK is being provided by the consumer, and now we are talking about at least once delivery. So in situation in which ACK is not provided, I will resend you a duplicated message because for some reason you didn't respond me with the ACK. At least once delivery is possible, at least exactly once delivery is not possible because of mentioned 2 armies paradox. However, what you can guarantee is exactly once processing. So we can provide you a logic within the code that will detect the duplicated messages, and this will be actually one of the next topics within this series. So I guess that was it when it comes to the theory, and now we are ready to jump into the code and see how these different guarantee models can be applied within our Superstore application. Alright, so before we actually jump into the code itself, I just wanted to mention one thing. So the code itself can be found as mentioned in this repository, so our DevMentors organization /messaging in distributed systems. And as you can see already, I have one pull request, so created by Dmitry. And in here, you can find that Dmitry found a very good point, actually. So we can even get back to the pull request, which says that the one thing that he noticed and that doesn't look good is the fact that I was using the exchange declaration within our hosted service, and this is actually a proposed solution. So the exchange declaration will be removed from our messaging background service and will be moved into our message subscriber. So this is exactly what we discussed, and I fully agree that this should actually be refactored in this way. So there is nothing more to be added rather than looks good to me and thanks. Submit review, and let's just officially merge it. Okay, so Dmitry, if you're watching this, thank you so much for the pull request. If you will spot anything else, your contribution is highly appreciated. So let's just do git pull. All right, so now we are back in our Superstore application, and I would like to start with describing and discussing how mentioned at most once delivery was actually done and coded in the episode number 1. So if we go to superstore.shared and in here to our subscriber, you could see that now we have this updated declaration for both the exchange and the queue. Then we have the consumer declaration, so how we are going to process the actual message once we'll have it delivered. And then we have this channel.basic consume, and we are specifying from which queue we would like to consume the messages. However, notice that the second parameter is called auto acknowledgement, set to true. So this effectively means that we don't need explicitly to put the code responsible for sending the ACK or negative ACK. It will be the client that basically does it automatically for us. So we can actually see this in action. So as you can see, I already have the breakpoint being put before we even, let's say, deserialize our message into something meaningful. So even before we execute the handler, we are already having our breakpoint. Let me run it. So first, founds microservice, and this founds microservice is of course our producer. The cards microservice is subscribing for our founds message. Okay. And if you can see, I already I'm within our RabbitMQ management dashboard, and in our card service EU many words queue, I can already see that for now we have 0 messages ready for the consumption, and also you can already see that none of the messages is unacknowledged, and the total is of course equal to 0 as well. So let's just send the first message and see what happens. So I will just run the specific endpoint, and I can see that I received the message. So I'm already on the card service side, being the consumer of the message. However, if I will jump back to our RabbitMQ, something weird actually happens, because you can see clearly that deliver happened, but as auto acknowledged, meaning that now the message is no longer being put into our queue. It's being effectively discarded because the message has been already delivered. Well, of course, if you think about this, this actually makes sense, because the message has been actually delivered. I can have a breakpoint in here. However, what can happen now is the following. I can just shut it down, and the fact that I received the message actually to me is meaningless. I didn't respond with the proper business logic to the fact that I received the message. So I can just see that now my queue is empty, and of course if I would try to rerun this application, so our cards microservice, now there is no message left to be consumed. I just need to send another one to have the message on my card service side. So I would say that in terms of delivering, it's not the best thing, because eventually I could lose it. Of course, it will be kind of hard to produce the actual network partitioning, but you could already think about the scenario in which I have some sort of network partitioning between my broker and the microservice, and the message is being acknowledged ahead, but it could be even the situation in which I don't have it fully received on the microservice side. So let's just change this behavior into something that we would like to have. So to our mentioned at least once delivery. So to enable at least once delivery, the only change, at least within this basic consume method, is of course to disable our auto acknowledgement. So let me change this to false and see what happens. Let's run the app once again. And of course, because we relied on the auto acknowledgement, the message is already gone from the queue, so we need to send another one. So let's do this. The message has been received. And now something interesting will happen, because I can of course execute this, and clearly we should see that we received the multiple word message. So we actually succeeded with the processing. This function has been successfully executed. And now when we get back to our RabbitMQ, something interesting happens. So the message is neither ready for the consumption nor deleted, because we can see that it's not ready for the consumption. Still we have some sort of message within the queue. However, it is marked as unacknowledged, meaning that technically we have it. However, we are still waiting for the ACK. If this will be delivered, the message will be considered as delivered, and we can remove it. However, for now, we don't know what's the actual state. Of course, the issue though is that we didn't put explicitly the ACK anywhere within our processing of the message. So the ACK will actually never get into the RabbitMQ back. The timeout for the ACK is kind of long. I'm not quite sure, but I believe that is now about the 60 minutes, so it's ridiculously long. I'm not certainly sure, so if you know the correct value, you can put it into the description. However, what happens if I will now kill this microservice? So let me just kill it. Okay, and see what happens. The message will get back from an acknowledged to ready. And we just need to wait for it because this dashboard is not that responsive. And you can see that now there is no unacknowledged message. It's ready for the consumption, and we have one message awaiting in our queue. Now, why is that? Because I mentioned that this will take a while. However, you need to remember one thing, which I pointed in the introduction. The ACK needs to be sent from the same channel from which the message has been consumed. So if and we know this already after the, let's say, first episode, the channel is basically built on top of regular TCP connection. If the TCP connection is gone, and you can see that now I have only my producer being connected and only one channel as well. So this means that the connection between the consumer and the RabbitMQ has been terminated, which means that there is no more channel, which means that I can already mark this message as not being acknowledged and put it back into the queue. Because if I will, run this microservice again, I will need to create another channel, and I won't be able, by definition, to acknowledge the already processed message. So this is very, very important. And now, of course, if I would rerun our application, I will get the same message being redelivered. Once again, the same message. Now let's add this ACK to our RabbitMQ, so we'll ensure that we actually got this delivered. And of course, as you remember, there are two things that we need to provide within the, let's now focus on the positive ACK. So first, the most important is the delivery tag. Now, just remember that within our received message, we also have the access to our basic delivery event arguments. Now, if I will just see the details, one of those is actually delivery tag. For now, it's set to 1 because we've just opened new channel, and remember that each of them is keeping its own current delivery tag. So we have the delivery tag equals to 1, and we also have very important information. The message actually is being redelivered. So it's not the first time that this microservice has ever seen it. Of course, if we would have multiple microservices and the other instance would get it, also the redelivered would be set to true. So it's not a difference in here. And also we have our routing key, so eucheck.republic. So now we have the information which says that this message actually has the delivery tag equal to 1, and we can provide the information to the RabbitMQ. So let's just stop this application, and after, let's say, handling our message, I would like to send the ACK. How we are going to do this? We are gonna to call our channel, and we have the method called basic ACK. And you can already see we need to provide the delivery tag and the information, whether we would like to acknowledge only one message or multiple. So in our case, I would like to provide the ACK for ea.delivery tag, and let's say that for multiple I will just now do false. So I'm not interested in acknowledging multiple messages. Now, when I will rerun this, of course, because I still haven't provided the ACK yet, I will get the same message again. However, this time I will just send the information back. So now we can see that from an ACK will actually get into the situation in which we'll have 0 messages in total because the message has been acknowledged, so it can be safely discarded from our queue. Simple as that. Even you can see in here that the message actually has been redelivered because it actually was, and the consumer provided the appropriate acknowledge to just indicate that yes, we have this being delivered. Of course, in our case, the message not only gets delivered but also processed because we executed eventually our logging. So we had this information somewhere in here. So that was our, let's say, processing of the message, which was also succeeded. Now, of course, at this point, we could play with it somehow. So, of course, I could now see how this would behave with the multiple messages. So let me do something very stupid, but it will just show you how it works. So I will create a very simple if saying that the EA.delivery tag, let's say, is divided by 4. Then I would like to provide the ACK with this delivery tag and with flag set to multiple true. Now this means that only every 4th message will get into this acknowledgement. Let me just run the microservice and you should see something quite interesting. So I have the breakpoint and now let's just send 4 messages. So 1, 2, 3, and 4. Now you can see that we are now have the delivery tag. So the latest delivery tag is actually 4. And we can provide the ACK with delivery tag 4 and with this flag called to multiple. Of course, if we will get back to RabbitMQ, now we have 4 unacknowledged messages. None of them is ready for the further consumption because the Rabbit is awaiting for the ACK. So we cannot give it to another consumers. So now we are awaiting for the ACKs. What happens if I will just run this program? You could see that in just a second, we'll have 0 messages ready. All will be actually acknowledged. And in total, we should have 0 messages because all of them were acknowledged at once. So it's once again very flexible in terms of the model, and of course you can adjust it to your situation. I would not maybe recommend doing the modulo in here, but it was just for the sake of the demo to present you how this multiple parameter actually looks like. Now, one thing though, which I mentioned previously, was the so-called prefetch count. So basically, just to remind you, it's the number that indicates how many unacknowledged message I could handle in the same time. And you can see that actually in our case, this number was not explicitly indicated. And by default, what you can have is the 0 prefetch count, which means that you have infinite number of concurrent unacknowledged messages. And we could see this, that we actually could handle more than once and acknowledge them at using just one ACK. Now, if you want to specify this number, of course you are able to do so. And this can be done by setting channel.basicQoS. And here you have 3 different settings. Now, as you can see, it's kind of confusing because there is prefetch size and prefetch count, and the question whether this applies globally or not. But for now, we discuss only prefetch count, and now there is also some sort of prefetch size. Well, the maybe not funny thing, but kind of weird is that those two are actually the same, and for some reason, this is not even implemented. So prefetch size has to be set to 0, and it's actually ignored, while the prefetch count is the only parameter that you should carry in terms of your code. And of course, I can prove it to you. Let's set this prefetch size to 1, prefetch size to count to 4, and the global to false. Run the code once again. And we should have the exception saying that it's actually not implemented. So as you can see, AMQP operation was interrupted, not implemented, and prefetch size was different than 0. So this actually, at least in the .NET client, needs to be set to 0, and just forget about it. So this is 0. Now what I'm saying explicitly is that my prefetch count equals to 4. So I can only consume 4 messages which would not be acknowledged. So let's see how this works in action. Let's just run our microservice. Okay. We still have this stupid if, but it doesn't bother us that much. And now let's send the messages we acknowledge all of them, so we have empty queue. And let's just send 5 messages. So 1, 2, 3, 4. We already are in here because, of course, delivery tag is 4. It keeps being resetted because once we run the microservice, we open new channel. So this is effectively being reset to 1. However, now I will just send a 5th message. Okay? And now see what happens. So 4 of them are acknowledged. However, 1 is ready for the consumption, is not being propagated, it's not being delivered to the microservice because we reached maximum capacity of the messages with no ACK being provided to RabbitMQ. So now we are awaiting, and once we'll actually provide the ACK and this will decrease, we can then further consume our next messages from the queue. So let's just do so. Let me click OK. And now we should see that the message should not be anymore ready. As you can see, it's 0 because it's now being delivered to our microservice. It's being awaiting for the ACK, and all those 4 previous messages has been already acknowledged and discarded from the queue. And that's basically the whole idea behind providing the ACK. Of course, what we covered so far was just, let's call this positive acknowledgement. I mentioned about 2 more, being negative ACK and reject. So let's see how this looks like. Maybe I'll just now remove it. Okay. For now, just don't bother us with the multiple. And just like we've done with the basic ACK, we can have, let's start maybe with NACK because it's quite similar. So basic NACK accepts 3 parameters. So first, as you can see, is delivery tag, obvious. Second is our multiple, so whether I would like to provide negative ACK for multiple messages or not. And the third parameter says whether I would like to requeue this message, so put it back into the original queue. So in our case, we can say that requeue should be false. And see what happens. Let me run the microservice. Okay, we still have 1 message being ready because we didn't provide the ACK previously. There was 1 is not divided by 4, so this is why we didn't provide the ACK. And in here, actually I didn't have the breakpoint, so I will need to provide this once again because you can see already that the message actually is gone, and I got the information that message has been delivered. However, there is no ACK, so there is no green peak in here, and you can see that the message actually was processed. So let me just maybe do the following. Let me just run it once again. Okay. All right, so we have it. Now, I will just send a message. I finished the processing. We could see that now we put this into our console, and I'm now providing the NACK with delivery tag equal to 1. Once again, new channel. We start all over from 1. And we don't want to put this back into the queue. So that's kind of weird because effectively this is quite similar to the ACK, right? In this particular case. So let's just run it further, and we should see that indeed the message will be not ready for the consumption because it's being discarded by Rabbit. We just don't forget about it. And of course, the only difference I would say when it comes to visual difference is that there is no ACK on the chart in here. So now let's do something maybe more useful. So requeue actually set to true. Okay, let's just debug. And I will just send 1 more message. So same story, I'm sending an ACK. Okay. And now actually have 3 messages, and that is 1 Czech Republic, 2 and 3. 4 and 5 and 6 and 7 and 8 and 9, and you probably know what is happening. So every time I am putting the message back to queue, but because I'm the consumer as well, I'm infinitely try to consume the same message over and over again. However, I have the basic NACK being provided, so actually this is some sort of infinite loop that I will not overcome. So in this case, no matter how many times I can even generate this in a kind of weird way, you should see that there will be quite a lot of messages, and we should start see that this message actually will never get into the state in which is acknowledged, because we don't provide so. So every single time, you should see already that we have like 300, 400 messages per second, because I'm putting this back to queue. However, this message is never gonna be acknowledged by Rabbit. So this is how this parameter requeue works. And of course, once we'll get into the actual message, I would say error handling, you'll see some other options that you might provide and what you can actually do within your messages that has not been acknowledged positively. So one thing though is that besides our basic NACK, we also have this basic reject. So reject was also considered as negative acknowledge. And as you can see, the only difference, as I described, is the fact that I cannot provide this for multiple. So now I can also provide the same requeue parameter and of course the delivery tag, obviously, but I cannot do this for more than one delivery tag. So just to prove it, maybe without this requeue, let us just disable. Let's just debug this once again, and this message should no longer be ready. It should be 0 because, as you can see, message has been redelivered. However, we did provide the reject, so negative acknowledged, and it's being discarded from the queue. So that's pretty much it about this particular message. All right. So that's how it looks. And of course, it's the matter of, I would say, the logic that you would like to provide maybe into your application to specify when this particular acknowledgement should be put. So whether you would like to do this after all the side effects has been executed successfully, or maybe in some other scenario, because of course I could bring this ACK even before I will decode my message somewhere in here, and that would act more like let's say at most once delivery. So once I have this callback being executed, I will just send you an ACK even though the message could be not processed. So this is quite a flexibility when it comes to this. So we as engineers can choose the one that is appropriate. And of course, one thing though is that this prefetch count, for now we had this set to 4. Of course, one thing to mention, if I will set it to 1, I will have this situation in which only one message can be processed at the time, which, as I mentioned, could be quite comfortable in some certain situations. So just to show you, say 3 messages. Okay, I need to put the breakpoint, of course, so maybe in here. So once I will just send the message like here, and now another message, we should see that one is unacknowledged and another one should just in a second appear in the queue ready for the consumption. So once I will just provide the ACK, now immediately another message has been consumed, and we should have 0 messages in here in the ready state, but rather now we are waiting for this last one to be acknowledged. Very handy in certain scenarios. However, of course, it does not improve your overall performance, because it just takes a while to process and grab another message and do this like in more like sequential ordering. So that was all about the acknowledgement on the consumer level. Of course, we also has the ability to provide an ACK on the publisher level. So how this can be done? So if we will jump into our message publisher, I can do something like channel dot, and of course there's quite a lot of methods, properties that you can see, and also some event handlers that I can subscribe to. So as you can see, I have the basic ACKs. So if I will do the following, so plus equals, of course, I can generate the handler for me. And I could do something, right? So let's say that for now I'll just create some sort of stupid text, ACK provided. Okay, and let's just put the breakpoint in here. And actually we have our found service, so our producer of the message being up and running. So I need to, of course, to restore this because we changed the code. So found service, the consumer is not needed for now. Okay, and now let's send the message. And as you can see, nothing happened. So the ACK was not provided. And of course, it's not because the message has not been consumed, because as I mentioned, the ACK is not about the message being delivered by the consumer. It's either whether the message has been rerouted to the specific queue, or if that was not mandatory message, or whether it was basically discarded because there was no specific queue to which I could deliver it from the exchange. So you can see that actually I have a message being ready, so something happened. I could even do the founds exchange to just prove that this actually has been published. However, no ACK has been provided. And that's because the publisher confirms needs to be enabled. So it's not enabled by default. Let me just shut down this and do the following. So confirm, or that was just the confirm. I don't confirm select, I guess. Yeah, confirm select. Now, when I will run it, okay, this should be now working. So now I'm expected to get some sort of acknowledge from the RabbitMQ once I will publish the message. So as you can see, I'm now within my my event handler, and with our basic ACK event args, I have even the information that this is the delivery tag with which the message will be actually delivered, and this ACK is not being provided for multiple messages, but rather for one. Of course, in this case, it would be slightly harder to show you how the NACK looks like, because our message, at least in this case, it's not set to mandatory. So even in the situation in which I can actually show you, if we'll have the exchange, which has no bounded queue, so there is no queue, it just goes to the def null, I can still send it and get the ACK. So let's just run the microservice and send the message, and there it is. Your ACK was provided, and that's because the message was neither mandatory nor persistent. So there was no special condition that needs to happen in order to provide you the ACK. However, there will be no an ACK, but rather some sort of acknowledgement called basic return, and I can actually copy this. So I will say that a return provided. Okay, and now let's see what happens. So in this case, I should have actually two sort of acknowledgement from, or two confirmation from Rabbit. First being the return saying that there is no route, and the other one will be the actual ACK. So let's see. I have my message being set to mandatory, but I have no queue being bound to my exchange. So once I will send it, I have the return saying that no route found. And the second is the actual ACK saying that the message was acknowledged. But of course, now you have the knowledge that this actually was discarded. There was not delivered to any sort of queue. So you can adjust your logic on the publisher side as well to create some sort of maybe some sort of more resilient solution. So in this case, when you have the return and this publisher confirm, you can somehow react properly. Or do something else, maybe because as you remember, now we are returning the task, completed task, because the whole publish is not a synchronous operation. Maybe you could think about something, I would say something more in a more asynchronous way. I mean the task-based asynchronous model in which you could create, let's say, task completion source. So task completion source. This for sure won't be the production ready code because there might be some sort of race conditioning, but if I will do tcs.setResult, and in here, let's just maybe forget about this. I don't care about this for now. So let's say that this one, so set result, I could do return tcs.task. And now actually, even if I would do async await, I don't need, I could pass this even higher. So return await tcs.task, like in this case, I could, actually I can do something like this. The return is no longer needed. I could turn my event-based asynchronous model into task-based asynchronous model, because I'm creating the task completion source, and only when I have the ACK, I will set the result, and this will allow my method to return the execution back to caller. So if I would do something like this and run it, you could see, hopefully, that this actually makes some sense. So I'm sending the message. However, you can see that it's still awaiting. So my whole execution has not completed. So it's not the fire and forget like it used to be. We are now awaiting for the confirmation. And now when the callback will set the result on my task completion source, this await will allow me to return the execution back to caller. So when I click OK, now this message has been actually sent. So one of the options that you could consider when it comes to usage of the publish confirms, or also all the scenarios in which you might have either this persistent message, or you would like to be ensured that the message has been actually routed somewhere, also quite handy in terms of publisher side, not only the consumer. So I would like to say that it's pretty much it. I know that there was not much code, but I just wanted to discuss in depth the ACK and the confirms both on the consumer and the producer side. And of course, as I mentioned, what we discussed was delivery guarantees. So effectively at most once delivery and at least once delivery. However, there is still a chance for us to process this exactly once. So not deliver this exactly once because it's impossible, but to process it. And of course, this will be the topic for another video. So we'll cover how we can actually make it happen, how we can detect the duplicated message. We already could see some sort of hint. So we have the attribute that we could use for this detection. And yeah, we'll build more, I would say, robust solution on top of the knowledge that we got today. So that's pretty much it for today. Hopefully you learned something new. Hopefully you have the deeper understanding about certain concepts and what the message delivery and processing actually is, and what is the line between the two of them, and how the different delivery guarantees can be applied within our distributed systems. Once again, I would strongly encourage you to subscribe our channel if you haven't so far. And if you want, you can join also our Discord community and subscribe or follow us on Instagram. So till the next time, see ya.